Hello and welcome to the next UILCS video, and in this video we're going to cover all you need to know for episode or for question 3 on the written test, which is print statements. So syntax for your print statement will go like this: system dot out, then your whichever one. So you can either have here you'll have dot print. The ones we're going to talk about are system dot print, system dot print line, and then lastly system dot print f. Okay. Anyway, so let's start our discussion with print. Let me just clear all this. So what does system.out.print do? Well, pretty much in simple terms, it takes whatever data you pass in and then it prints that data out to the console. So if this green arrow represents a line in the console or terminal or whatever, it'll take whatever data you pass in and then print it out. And your data can be anything. It could be a string. So here, if I took this line here, why am I on the snipping tool, bro? If I took this line here, just copy it for future reference. Think of it, it's kind of big. So your data could be a string. I could have a string like hi in here. And then what would our console print out? The console would print out hi. I could have, and I'll just use this. I could have maybe a variable in here. Like I could maybe even have, let's go up a little bit. Let's say I defined an integer. And I'll call it a, and we set it equal to 5. I could pass in that variable as your data, and then your console will print out the value 5. So it'll print out the data. So you can pass in strings, you can pass in variables, you can pass in function calls. Right? You could maybe pass in a little function in here. And then it will just give you whatever is returned by that function. And I think we're going to cover functions later, so don't really worry if you don't understand that right now. You could, and then the last thing you could even do is, or I want to cover right now is some math. So you could do like 1 plus 2, and it would return and print out 3 to the console. Okay, so that's pretty much, you can put in whatever data you want in, and that's the data that will get printed out. I mean, in more technical terms, we're going to cover this when we talk about object-oriented programming, but your data has a toString function or some sort of code telling Java what it should look like as a string, right? And then whatever that is, it's what gets printed out to the console. So here, right, when I put in the variable a, it's not going to print out a. It's not going to do that because there's some sort of method or something in the variable, this int variable, that tells Java, hey, when I call this variable, print out 5, don't print out 8, don't print out 8, just print out the value I stored, okay? But for what you need to know for the test, just know that's how print works. Whatever data you put in, it'll print out its string representation. And going through some examples, really just know that you can do out. So the main things you're going to see probably on the test is you can pass in variables, you can do arithmetic, you can pass in functions, they have return. Anyways, oh, there's one more thing, but the unique thing about print is, let's say I had two print lines, each printing out some data. Okay? And then I had one print line printing out data, and another print line printing out some other data. Well, in what would actually be related to the console is, first it would do this line and then print out your data. So it would run line 1 and print that out, which makes sense. Holy moly, I can't type, bro. Right? But then when it gets to the second line, it's not going to move on to a new line in the console. It's going to print it out in the exact same line. So right next to your first print statement, right next to this, it'll print out this. So the way print works is it keeps it all in the same line. Yeah, so as you can see here with the print line, it basically takes your data and puts it on the same line. So if I go to IntelliJ and I don't even think they have one that's just print. Anyway, so if I just do system.print, you can test what I said. So you can print out a string. It's like this. You'll see a string will get printed out. You can create a variable. So your a is equal to 5. You can print out a. You'll get 5. You can do math in here, and let's actually do variable math. So we'll do 5 plus 5. Let's run something like this. A plus b times 2. Now if you remember in the last video when we covered operator precedence, the multiplication has higher priority over the addition, so it's going to be b times 2 is 10, and add that to a. So I should just get 15. As you can see, you can do math and stuff. Pretty cool. You could maybe, if you want to do a Boolean expression, yeah, it'll work. It'll give you the value of the Boolean expression. But I'm saying anything that you can pretty much put any data here, and it'll have some string representation, and it'll give it back to you. Okay, as long as like pretty much, I'm pretty sure as long as see like something like this in valid Java code, but essentially your options are kind of like, well, not limitless because you couldn't put this in here, but any like expression or any condition stuff you could probably put in here. I don't know like the full-on ins and outs, but just yeah, so you can put data in here. And for the UILCS test, question 2 specifically, if they're going to ask you about print, it's most likely just going to be something like this, with like some sort of like mathematics with this print line. Or you just solve the math and you just get a print value. But also, like we were talking about earlier in the paint, if I do, don't worry about print line, we'll talk about that later. If I do hi, and then I do another message like, this will be on the same line. And I'll make this will be on line 1. And then this next one says this will be on the same line. Watch when I print it, see, it also is up on the same line. There's no spacing, there's no nothing. It's the direct string that we put in, and then the next string, just like that. It's now on a separate line. I may be asking, Sid, how do I get my data on separate lines? Well, this is where the system dot out, sorry, messing up my colors, dot print line comes in handy. You can do the exact same things you could with print. However, when I print, let's say some data, it'll print it out to the console, whatever data I printed, or whatever data I put in, the string representation, and then it'll move on to the next line. So we'll kind of be over here in the console. So if I had something like system.out.println data1, and then I had some other data right beneath it. Let's say they're two separate datas, right? Like similar to this example, this line over here would print out. So let's make sure we're looking at this line, and it's gonna print out the console data. And then it's gonna move the print to a new line. Next, we're gonna run this second system.out.print. So it's gonna go on this new line now, get printed. And what's important to know is that it'll make a new line, right? So print line doesn't really like when you run this first line, it doesn't just do like this and leaves it here. And then the second print line is like, okay, we have to make a new line. That's not how that works. How it works is your first print line prints the data, then moves the console onto the next line. So then when it prints out this data, it prints it on this line, and because it's a print line, it'll also move the console onto the next line. So you can kind of view it as just printing out the data on whatever line we're on, and then moving on to the next line. It's not create a new line and print out my data there. That's not it at all. Okay? And I can show this in code too. So, like I said, you can do the exact same things you could with print with this. Just do like, I don't know, some math expression or something. And then see, look at whatever it outputs to, 21. You can print out variables. And it'll get you the variable, and don't worry why, it's kind of weird why it's written like this. Java doesn't really consider indentation for anything unless you, that's why we use brackets and stuff, because indentation doesn't matter in Java. Like I could write this as, and I'm pretty sure, yeah, this is still compile. Yeah, 5, okay, yeah. Kind of an extreme example, but yeah, indentation doesn't matter in Java. That's why we have brackets. But yeah, the key feature here with separates it from print. This is on line 1, so let's say I'm printing out a string like this. And then I was printing out another string. This is on line 2. So as you can see, this will be printed on line 1, and this will be printed on line 2, and we have room for one extra line here. First is if I made this print, you see how there's no extra line at the bottom here? How it just prints it out, and then it just ends. So you can clearly see, right? The way it works is it prints out the line, but it prints out whatever data is on, and then moves on to the next line. That's why we have this space here. Okay? So it prints out the data on whatever line it's on, moves on to the next line, prints out the data on whatever line it's on, which would be line 2, and then moves on to the next line. That's all I'm trying to show right now. Print out data, moves to the next line. Prints out data, moves to the next line. And I want to specify this because they know you understand print and print line. If you're going to see this in a test, it's probably not going to be on question 3, it's going to be on a question. They're going to ask you for, they're going to test you on like mixes. So they might have a system dot out dot print with some data inside, just like that. And then they might ask you, I'll write it out, system dot out dot print line with some data, and the answer choices are gonna be like output and stuff, and they're gonna want you to be able to correctly give them the output. So I can just for all we really need to know right now is what happens when you have two prints following each other. The output when you have two print lines coming out of or following one another. When you have something like this, when it's print and then print line, what's going to be printed to console? Well, what first is going to run? Java is going to see, okay, print out data, and because it's print and not print line, we're going to stay on this line. So then this line is going to run, and then I'm kind of using green interchangeably here. Just ignore green. Just like, no, this is the console. It's going to print out the data. Okay, remember, it doesn't move on to a new line. It doesn't do something like this, where it moves on to the next line and then print that data. No, print line prints the data on whatever line it's on. So this one. And then we move the console on to the next line. So this would be your output. You'd have your data here and then a new line. And I can store that in code. So I'll say test with just print, and this would be line 1. And I'll say test with, for uniformity, test with just print line. Okay, let's run it. So you'll see that very same thing. The data is on the same line, but there's a new line because what? Print out this data and keeps the console on the same line. Print line prints the data on whatever line it's on and then moves the console to the next line, as you just saw, just like I described over here. So what if we swap the roles? What if I took this line, paste it here, let me delete this. Let me just clean this up a bit. And then what if we took this line and pasted it below it? So it's gonna look something like this, right? We have system.out.print line on top, and then you have your just print at the bottom. So, well, let's just go through it. First, your print line will be done. So it'll print out the data whenever line it's on. Then it'll move the console to the next line. Then your print will be done. So it'll print the console on whatever line it's on, which would be this one. And because it's print, it doesn't move the console on to the next line. So I can test that over here. Print line. And then we'll just swap it over here. And now if we run it, you'll see that exact result. Data on one line, data on the other line, but wait, notice how in the previous example, we had an empty space here, indicating the console was on a new line. Yeah, in this example, what did I just do? How do you redo? Okay, fine, I'll just rewrite it. Go like this. Okay, let's just rewrite it. Versus in this example, you can see that there is no new line because we're working on print. The last line was print, and print stays on the same line. So if I had, let's do a little bit of chaining. If I had a print here, another test with just print. Well, we're still on the same line, right? So this will print it out on the same line. And remember, we're still on that line because print doesn't move the console to the next line. Then let's say we had a print line. Test with just print line 2. Well, you'll see we're still going to be in the same line and we'll have a new line here because print line stays and prints the data on whatever line it's on and then moves on to the next line. So if we had finally, let's say one last line, you'll see that now this data will be on the last line and we'll have a new line. So let me just walk through what happened here. We ran print line, which prints the data on whatever line it's on and then moves on to the next line. So it printed all the data on this line and then we just moved on. Is there a way for you to like highlight from left to right? Yeah, there we go. Print the data on whatever line it's on. Okay, sorry. I'm getting ahead of myself. Okay. So let's go over what this code actually does. Test with just print line. So we have this first system.out.print line with this data inside. So what does it do? It prints out that data on whatever line it's on and moves the console on to the next line. Okay, so that explains how we're on line 2 now. So we're going to run this test for just another print. So what does print do? It just prints the data on whatever line it's on and keeps the console on the same line. So when we run this another print line, another test which is print, it's going to print the data on whatever line it's on, and again keep the console on the same line. And in this print line, it's going to print the data on whatever line it's on, but then it's going to move the console to the next line. So that explains now how we're on this line. And then so this last print line is just going to print out the data on whatever line it's on, and then lastly move the console over to the next line. So if we just remember that print line prints the data on whatever line it's on, then it'll move the console to the next line, versus print printing the data on whatever line it's on and keeping the console on that line. You won't really have any issues with the difference and with those problems that chain print and print lines and print and ask you to give the right output. Now, it's important that we discuss this in this video because you're going to see it on tests, on written tests, but for in terms of question 3, what they'll, I wouldn't say 100%, but what they mostly test you on is this last print statement. I don't know if it's the last, like I'm not going to say this is the only definitive tree. I know of tree. And they only test you on tree, so. It's going to be system.out.printf. Now the input for this is a little bit different. You're going to have your formatted, why am I doing it in green? Your formatted string here. And then you have your corresponding variable, so like var1, var2, var3, so here's your corresponding list of variables. So the main parts of this is you're going to have your formatted string here, and then your list of variables here that are all comma separated. So let's focus first on what the formatted string is. So first let me talk about what printf is. So printf is a way of printing a formatted string, if that makes sense. So if I wanted to print out, let's say I had a string, right? So I had a string, and it's a name, and then the name is like Sally. And then I want to print it with, and maybe Sally owes Bob this amount of money. Owed like $42.74. So to the thousandth of a cent, or 10,000 of a cent, I think. Right? Money. Well, what if I just wanted to print out the console? Sally owes $42.39. This is where print formatting would come handy. As print formatting allows us, or is one way to print multiple variables on the same line or different data types, like this Sally is a string, now I've abbreviated with str, and then this 42 was a double. But the unique thing about it is it allows us to format strings in other ways. For instance, it allows us to set the precision for doubles, and it can do much more things than that, but that's one we're going to focus. We're going to go over all of them, to be honest, but That's an example, right? So it really just handles formatting strings, combining different variables together, like I said, a list of vars, and then pretty much formatting them in ways we want. Like maybe we want Sally to be, or we want this whole string to be left aligned. Well, you can do that. Or well, no, that's a bad example. What if I wanted, let's say it's money, right? What if I wanted, instead of also being money, I wanted to show the sign of it. I want to show if it's positive or negative. There's a way to do that. Let's say I had a string A and it contained hi. It contained some characters. Well, what if I wanted to offset it? What if I wanted to print out 0, 0? Or what if I just want to right shift it by like 6 spaces? So 1, 2, 3, 4, 5, 6. And then I want to hide the printout. Well, there's a way to do that too. So pretty much all your formatting needs, whatever you want to do in terms of formatting, like if you want to, let's say you had like some negative numbers and you had positive numbers and you wanted them to show up on the same line. You want them to kind of look like this, where they're all nice and neatly aligned. Well, there's a way to do that with formatting. All of your formatting needs can essentially be solved with printf. That's why we use it. Now, let's actually explain why it's or how to use it. So, everything we see, all the variables and stuff, and from the formatted string can be represented as format specifiers, or by format specifiers. So, %s represents a string. %d represents an integer viewed ds digit. %f represents a float or a double. It's how you can commonly see it used as any floating point number, any number with decimal points, or any number with values after the decimal point. %f. So if we went back to that original example, so string name is Sally, and we're not going to worry about precision right now, so I'll just have it automatically precision or shortened. Ode, or O's probably makes more sense. 42.38 we'll say. Well, if we want to represent this with some printf formatting, we would do system dot out dot printf, and then let's compare it to if we're doing normal printing. So let's say we had a print line up here or something. Well, if we're doing this normally a print line, it maybe look like using string concatenation, name plus space O's, then a space plus the variable we have for O's, and then we might have another plus for with a space dollars, right? So this is how you could represent this with string concatenation, but printf you would represent this as name would be your format specifier for string, because that's what type it is, which is %s. %s O's, and then you'd have what we had, the variable for O's which we said can be represented to %f, because it's a double, dollars. And then you would have your list of variables. So we would have the variable name here, and the variable O's. With this relationship. Right? So these are two different ways of representing the same thing, and you can see that this one is way shorter than this one, right? And it's way easier, it makes more sense. This is how commonly you're going to see it. It's way more easier to use printf too. The main takeaways you got to understand is %s refers to strings, %f refers to doubles, %d refers to integers, and there's more, right? But these different format specifiers refer to different data types, right? And you can see here I'm asking, Java is expecting, because of your format is string, that you're passing in a string variable first and then a decimal variable or a double. So that's why we start with a string and then we go on to our double, because Java is position based. It's expecting a string first. It's going to look in our list of vars for a string first, and then it's going to use that. And conversely, then here we're going to look for a double and we're going to use that. If you had %s and then let's say name was a integer for some reason. If it was a type of integer, then our code would crash because Java's like, yo, you're looking here, they're telling me you want a string, but your first argument is an integer. That doesn't work like that. Okay, so that's like much how it works. It's position based. Your first format specifier must correspond with your first variable in your list of vars, and then vice versa. And we can represent this with code too. So let's do the exact same example. Have a string, call it Sally, or sorry, call it name, is equal to Sally. We'll have a double, O's is equal to 42.38. And then we can do soof for printf, if you're on IntelliJ, %s, O's, %f. And you can actually already see it's a little yellow underline. Too few calls for format string, because if we're asking for if we're asking, hey, this will be replaced by a string, this will be replaced by a double, well, Java wants to see a string and a double here. So string name, double O's, right? If I made this D for a digit, well, now I see this yellow underline because boom, argument type double does not match the format specifier D. Java is expecting you to pass in an integer and you're trying to pass it a double. It doesn't like that. If I had let's say I had some additional information, like in this some integer age years old, well now Java is also tweaking because you're asking for 3 variables now, but you're only passing in 2. Versus if you had like more variables, or it doesn't have to be a variable either. It can be values too, right? If I had more variables than I did for my specifiers, Java would also get confused. Like you're asking only for 2 variables, but you're passing me in so many, okay? So the amount of variables you have and the amount of format specifiers you're using have to match up. And the type of format specifier you use has to match up to the type of your variable. So %s for string, so that matches, Java looks for a string, boom, string. %f for a double, Java expects a double as your second one passed in, boom, double. Okay, so actually when you run this, you'll see you're getting this, and you're actually getting this, which we'll talk about really soon actually. But yeah, so you can see that we can roughly do the exact same thing. So one more time, let me just explain what this line means. It's basically saying, okay, first you want me to get a string. First you're telling me that you're passing me in some string. So first I'm going to look for a string. Okay, no, here. So basically, let's go over this line it's saying one more time. It's saying, okay, you're doing %s for string, which means you're going to pass me a string as your first argument. So I'll check for a string as your first argument. Oh, boom, there's a string. Yippee! Going over to %f. Okay, now that's your second format specifier. So I'm expecting a double %f as your second variable. Boom, matches, goes like that. Like, look, if I made this %d, it starts tweaking out because, hey, I'm looking for an integer from your first variable, but you're passing me a string. So that's the general basics of and print f. Now we're gonna dive into detail. So much more detail. First of all, let's just go over more format specifiers. You're gonna have %b for Boolean, percent what other good types would there be? I think do %n for new line, because if you also look at my output, right, we're on the same line. So if you're gonna tell Java you want me to move on to a next line after, you need to outlook %n, and now look, boom, new line, bada bing, bada boom. There's also some other stuff, %t for tabs, kind of irrelevant though. Okay, let's pull up a list. You also have %c, which is for any character. You can have you have various percents for different types, like %o for octal. You have %h for hexadecimal. Or no, sorry, not h, x. For some reason, x for hexadecimal. I'll just sort it to that. We all talked about that. Stuff about date, time. Oh, and then one more thing, probably I've seen them test you on is %, right? Let's say you just want to print out a normal % symbol. That's how you do it. So I go into Java and then I write something like this. Java's gonna start tweaking because like, hey, you're giving me a printf, but you're not passing me in anything. See why it's gonna error out? Yeah. So if for some reason I'm making a printf statement, like let's say this is Sally owes, and this is a percentage of how much she owes. Excuse me. Then it might make sense to say Sally owes %f, and then you want that as a percentage. We're saying it's a percentage. And then now if we run this, 42.38 something 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 percent, right? So these are all the various symbols. These are all the format specifiers that you need to know. Now, there's more to a format specifier. Those are kind of symbols, like this relates to that, this relates to that, yada 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 yada, right? But in truth, your full format specifier can actually look something like this. And it's going to be a lot, so I'll break it up into different colors. Maybe that'll help. You can have your index, followed by $. You can have your flags, and I don't want to do it in yellow. Let's do it in this gray. Your flags. You can have your width, and then you can have your precision, and then you'll have your, I guess you can call it like a format character. and that is the %s, and that is your %s yada yada yada. It's this character, yeah, this stuff, B, N, C, S, D, F. And this is also the order you have to specify it in. It goes precision, width, flags, index. You don't have to include all of it, but you can't try and define precision before width. Okay? Java does not like that. So let's break these down individually. Let's start off with precision. So if we noticed back in our output, I'm having 6 places after the decimal point. And why is that? It's because whenever you give Java a decimal, you have something like this, right? Java automatically assumes a precision of 6. So this is the precision. What precision means is you're going to place down a period. So it's saying after the decimal point and your precision. So how far out past decimal point do you want me to go? Right? So if we return to this example, if I made this like, it doesn't have to be, but if I said %.4, then you will see we only get 4 places after the decimal point. If I made this %10, I think, yeah, we would have 10 places after the decimal point. So you can kind of view it as the decimal point, and then your precision, how far past the decimal point do you want, or how many decimal values past the decimal point do you want to be in your output. Now the important thing to know about precision is that it rounds. Okay, so it will round. So if you return back to our example, look at this 42.38. Let's say I just wanted 1 place after the decimal point, so I just wanted this. Well, if we run that, you can see it actually rounds up to 42.4. I'm kind of curious, does this do anything? No, okay, it's tweaking. Yeah, malformed because this is minus sign is a flag. Anyways, ignore that. I was trying to test something. But that is the percentage one. Okay, you can't do. All right, actually accept that. I wonder what this look like. You specify something like this. I guess the zeros here don't really do anything. But anyways, yeah, just don't worry about the zeros. Look at this. This is how you're gonna see it on the exam. Dot and then whatever position it wants. So if on the test it might show you something like this. Double A is equal to 52 point this, and then you'll do a percent dot tree f with A, and it might ask you is the output 52, A 52, B 53 for some reason, C 52.4, C 52.432, and then D 52.433. And then the correct answer here would be D, because it's gonna round it up. Yeah, see, like that, boom, because it rounds. That's how you would see precision tested on your UILCS written test. Okay, that's precision. It's pretty straightforward, pretty easy. We just have to make sure you remember that it rounds. People forget that. Don't forget that it rounds. And make sure you don't forget the decimal point too. Okay? Because when you focus on the width, that's just numbers. So if I had percent, what does width do? Width tells Java how much spacing you want between your elements. So if I had %s, and then let's say it's like some string, and then the string is just like, maybe I'll say it's a character like s. I don't want to do S. Let's just make it let's just make it high. Why not? Alright, so let's say this is what we had, inside of our printf, whatever. When you print it out, you will just see to the console this. High. It'll be completely left bounded. If, however, let's say we added a number like 5 here as the width. Well, now what Java's going to do is going to add 3 empty spaces here, 4, 5, such that the total width of your output is 5. So you can see I put in 5, 1, 2, 3, 4, 5. Okay? If we increase this, I can just show it to you in code. Well, that's IntelliJ, or no, that's VS Code. Let's close that. If we go here, do soof %5 s, and here it's going to pass in the string hi. You can see now it's going to print it out, and we're going to have a total of 5 spaces. So I guess for simplicity, for matching up with the paint, we're just going to do it like this. You can see here how we had 5 spaces, 3 empty spaces, 1, 2, 3, 4, 5. Here we also have 5. 1, 1, 2, 3, 4, 5. So you can pretty much just view print as you're basically telling Java, hey, I want you to print out high, but I want you to have it like 5 spaces. Have it have a width of 5. Java's gonna be like, well, high is only 2 characters, so I'm just gonna add 3 empty spaces, 3 white spaces to give your final output a width of 5. Okay? And the reason why I say checks its output originally, if I said hi, hello, you're gonna get 0 white space. Because you're saying Java, hey, I want a minimum width of 5. So I want my final output at least to be 5 characters long. Well, this is way more than 5. Versus this, which is 2 characters long. So I have to add 3 empty or 3 white space characters to get you to that 5. Now, if you don't have to have your white space shift your code to the right, you can have it like this by indicating a little negative sign here. So if you said -5, Java would add the white space after your high, or after whatever data you pass in. So let's demonstrate that here. Make that -5. And now we have our high here, and then we have 3 empty spaces. Okay? So now you can view this negative as a left aligning tool. It'll take whatever data you passed in and make sure it's just left aligned. So if I ran this, oh, okay, actually you have to use this flag with a width. I didn't know that. But yeah, so you can see here -5, so we're just gonna print out data and then add all the empty white space we need to reach 5. Exact same premise as over here, we're still 5 characters long, except over here the white space was added before the data, before the string, and then with this negative, white space was added after the data, after the string hi. And conversely, if I did hi hello, if our data was longer than 5 characters, nothing would happen. There'd be no white space printed, because Java would be like, hey, your data is already, and here I can say like this. Yeah, see how I can't extend my cursor anymore? There's no white space, because Java will be like, hey, your data is already more than 5 characters long. Remember your width, and I'll say it again, is a minimum. Width is a minimum width. So Java would be like, hey, your data is already 5 characters long, there's no reason for me to add any white space. Okay, so we talked about those two flat, or we talked about how you can add a negative to your width, right? Well, you can also add a 0. And what 0 will do is it'll 0 pad it. So let me describe that. Also, important to note is using the zero flag, it only works with like number-based format characters. So it wouldn't work for string, but for integer, double, octal, hexadecimal, it'll work. So let's just do a float. If I were to pass in that float, like what, 42.31, I'm going to store it this time. You can see here it's going to print out 0, 42.31. Or sorry, this actually wouldn't print it out. We need this to be 6. Let me delete that. Oh, my delete key's not working. Oh, I'm pressing home, bro. Okay. 0, 6. There you go. So you'd see, because now Java is basically the exact same thing we described earlier. Java's like, oh, you want 6 spaces? Okay, I'll make sure that you have 6 characters. And then instead of filling this empty space with white space, we'll make it a number. So we'll make it like 0. So you can see that over here, and see I was trying to test it with a string, but that's illegal. But if I made this an F, then I made this 1, 2, 3, 4, or 12.34. First of all, you see that no 0 gets printed out. Okay, except for these ones. So we can actually just, because remember I said earlier how your default precision is 6. So if you're just using if you're using F as it normally is, Java will print out your decimal with a precision of 6 after you have 6 zeros. So I'll just run it like this, and you'll see, yep, no extra zeros added to the left or anything. If I wanted a width of 10, however, I'm still passing this in, you're gonna get all these zeros. And conversely, you'll notice this negative doesn't work for some reason. And that's because of significant figures in math. Okay. The reason you can't make this negative is because it doesn't really work with decimals, but I don't know why I don't know why I don't like have the decimals. I guess I just hate it, I guess. Oh, I know why. It's because if I define a precision of 2, which is what I did, and then I'm trying to make this negative, it's going to add all these zeros here, and it's going to add a 0 here. 1, 2, 3, 4, 5, 6 to make sure I have 6 characters. As you saw before with just a normal negative width, it'll add that white space and that 0 to the end after data. So it'll add that there, but that kind of contradicts what I wanted, right? Because if I had a 0.2f and I want it to be shrunken, I want it to be this, then by adding a 0 here, that kind of contradicts what I want. Contradict isn't even a word though. Okay, and conversely, if I had, let's say I was passing an integer, well, 4,231 is very different from 42,310, right? Decimal or zeros, even though they're zeros, expand the number, when you move them to the right, expand the number like crazy. But if I had them on the left, well, that's just still 4,231. Same thing with here. If I had it to the left, well, that's still just 42.31. So mathematically, we're still valid. I mean, that makes sense, right? Because if you're using printf, printing out these data, printing out with these format specifiers with this precision, you don't want this negative to mess everything up, you know what I mean? So key takeaway, negatives and the 0 flag cannot be used together. Then the 0 flag is only used for number types. Right, let's do a quick width recap because there's a little bit more in width than there is in precision. Or we can just quickly go over both right now. So precision is specified with a dot beforehand, and it indicates how many spaces after this 0 you want to include. So how much past decimal point. And it defaults at 6, so 6 is default. And you can also do precision with strings. So if you're looking at the string, and I'll just play it over here, A, B, C, D, E, F. Let's look at the string for instance. And then we're asked for the precision 2 of that string, right? Let's say this is in some code. Well, pretty much what Java does is it goes up to but doesn't include that second index. It starts at 0, 1, 2, stops here, doesn't include it, and it'll print out AB. So that's precision with a string. And you'll see this idea of starting your index at 0. I think we already covered starting index at 0. And then stopping before the last element. Or stopping before you reach that whatever number you gave. Concept, we'll talk about substringing, which should be in the next video. To test this out, let's do 0.2f and then 0.2s, sorry. A, B, C, D, E, F, G, and you should see that we're just going to get A, B printed back. Yep, A, B, boom. That is precision. Now let's move on to width. So when you define your width, you're saying how many characters you want your total string to be. So, right, for instance, a width of 5 means that you want your total string plus your data to be 5 characters long. Okay, so 5 char long. And you have to remember that width is a minimum. So let's say if I was passing in the data hi, and then it would look something like this, right? 5s. Well, because hi is shorter than 5 characters, we're going to have 3 bits of white space. And then we're going to have hi. So that way we in total have 5 characters. But then if this was like hi with like a lot of i's or something, enough to make it go over 5, you won't have any of that white space. Because Java's going to be like, hey, well, your string is already 5 characters long. There's no need for any white space. You're only using the white space until you reach that 5. And then in addition, if you make it a -5 or something, it'll, instead of placing the white space before your data, it'll place it after. And then for integers, numbers, that type of things, you can use the 0 flag. And what that'll do is, it's the same premise as how with the string, like we had hi and stuff, we had h, I, and 1, 2, 3 right after. For 0, it'll be the same thing, but for numbers, so if I pass in 12, it'll be 1, 2. Oh, sorry, no, sorry. I was right originally. Yeah, so let's say we had a string. It'll be like this, 1, 2, 3 spaces of white space, and then hi to make 5. But then for 0, if we're looking at a number, it'll have 1, 0, 2, 0, 3, 0, and let's say our number is like 12 or something to make 5. So exact same concept, you just replace the white space with zeros, and there's no negative. There's nothing like 12 and then followed by 3 zeros to reach 5. Because that changes what your number means significantly, so it changes it a lot in a mathematical standpoint. Okay, so that is width and precision. I just wanted to do a quick recap of that because I'm going to delete all this now. And we're going to move on to flags and then index. So you've actually seen, alright, let me clear this out real quick before I get to yapping. You've actually seen some flags in action before. If you might have heard me call it like a zero flag or something like that, right? The zero and then the negative we're talking about are both flags. Why? Because when you put in zero, you put it after the wood. So if it was 5, you put 0 before it. You wouldn't write 5, 0. You wouldn't do that. You'd write 0, 5. In all the examples I did that. If you're doing negative, you do negative 5 to left line anything. So you'll see what comes before with flags. These are flags. So let's talk about some flags. So we've already covered the negative and the 0 flag. So I guess another flag is this flag. And what's my color? Yeah, it's gray, right? The hexadecimal, or not the hashtag flag, which will take any number that you give it, any like octal, any whatever, and reference it and like make it look in a different format. I really don't see them ever testing you on this. But we can run an example of it. Excuse me. If I did like hashtag O, and then I had an octal of like 1, 2, 3. I'll delete this. So you're gonna get it represented like this. If I had a hexadecimal, 1, 2, 3, maybe A. Could you write like this? Would it accept that? No, it wouldn't. Oh, because yeah, you're just running your base 10 equivalent. It kind of converts it. It'll write it out like this, and then you can compare that to this output, which would just be this, or this output of what do we have before, like 134 or something, which just be this. So you can kind of see like it's a little bit different. There's like a 0, X. You only do a 0, 8. They have 0 for the other one. But yeah, just a different format. And I think it's cool that you guys got to see this, what this does, because pretty much with these octals and hexadecimals, they didn't really cover them that much, but they just take whatever decimal value you're putting and returns it in that form. 137 and base 16 is 86. I don't think they have a binary one. Maybe they do. I haven't heard about it. Anyways, the next flag we're going to go over is the plus flag, which they probably could and might even would test you on. So this one is also really just pretty self-explanatory. It makes it so the sign of your thing is always shown. So if I had a printf statement, I'm not going to write all that. Let's just say I had like in here, right? I passed in negative 42. And I had here percent plus d. Well, this would print out negative 42, which it would have done anyway. So there's not really any use to the plus when you're working with negatives. However, if this was a positive 42, like this, and then you ran it, there would be a use because it would print out plus 42. The indicated number is positive. So other people have really just described it as showing the positive sign. You can look at it however you like. Next we have, we can do the, let's do the parentheses one. That one's kind of cool. Okay. Next one we're going to talk about is the left parentheses. So it encloses negative numbers in parentheses. So if I had a print line statement, which was 42, like this, right? And that's not C, it's supposed to be the left parentheses. Well, this would just print out 42, nothing would really happen. But if we made that a negative 42, well, now we would get this. It's not printing out negative, it's printing out parentheses around that negative value, which would be for, or around the absolute value of the negative value. It's like this. Okay. Next one we're going to talk about is the comma. And then what this comma one does is it'll pretty much like, I don't know how to describe it, but if you're passing a number like maybe like comma format is the right word. For instance, if you passed in 1000 and then you did something like this, then you would get something like this. So you see a commas here, right? That's how we typically write it. That's what the comma does, just adds commas to kind of separate the values. And you'll see that one thing I want to pay attention to and let you know is that most of these things like this, yeah, okay, this hashtag, this plus, this left close, this a comma, they all work for numbers. They don't work for strings. Pretty much all of these flags work for numbers. Like even the 0 flag worked for numbers. The only main flag that works with everything is the left justify or the negative sign flag. That works for everything. Okay. Why do I keep opening up until it's let's also just run through all these flags again. And you don't have to worry about negative because don't view, okay, sorry, there's a little bit of a side tangent, but don't view 0 and negative and context with flags per se. View them with context for width. That's why I describe them with width. They work with width. Right, like if I wrote 0x, that doesn't work. You need a width specified. If I wrote negative x, that doesn't work. You need a width specified. They work with width. But if I wrote plus, oh, sorry, I think this doesn't work with all numbers. It only works with some. Maybe because this plus sign doesn't really, if you want to look at, I guess it doesn't work with every number. Maybe probably because hexadecimal and octal don't really have clear negative types. They don't have a negative sign representation. Like remember when we talked about two's complement, when you convert things into negative numbers, different bases, it's not like you don't get a negative sign. It evaluates to something. So that's probably why it doesn't work for that. But yeah, you can see we'll just run through some of them here. The plus, input a positive number, shows in that positive number, shows the sign. Input a negative number, shows the sign. The sign is shown. Let's talk about this one. And let's pass in the number. Let's pass in 100. Well, you'll see it's not going to be a 0 because 100 is normally like that. But then if you pass in 1000, it'll oh, sorry, wrong one, bro. I was thinking the common. If we pass in 100, 100 is a positive number, so it'll print that out. But if we pass in negative 100, it'll print it out in parentheses. You'll see the absolute value in parentheses. Now we'll talk about the comma one. If I print it at 100, you'll see nothing will really happen because 100 doesn't have a comma grouping. But if we put in 1000, you'll see the three zeros are separated like they are in normal math. 10,000 works normally. 100, let's add in a bunch of zeros. It'll print it out normally. Like 1 billion there. That's a lot of zeros, man. Okay. Those are the flags. Now the very last thing left to cover is the index sign. So I think earlier we discussed how when you're writing this, when you're doing this, yeah, over here, it's position based. So if string is your first format specifier, they expect the string passed in as your first variable. If a float is your second format, if a double or something is your second format specifier, they expect a double or float as your second variable. Well, that doesn't necessarily have to be the case with this index parenthesis or index dollar sign. And one thing to note is the index for this example is 1 based. There is no 0. And that kind of makes sense because 0 is used for a flag and stuff. So I think it might confuse Java to see it again. I think that's maybe the reason why they made it 1 based. So essentially, let's look at this example. Let's go back to that example of Sally O stuff. So originally we had like this. Sally owes %f. And then I had here the variable name and then the variable owes. Right, so something like this. Right, so we'll match it up like this, match it up like this. Well, what if I wanted to just start off with O's for some reason? Like what if I wanted all my string variables, like I was very particular about this. I want all my string variables to always be last. So we can rewrite this like this. And then, well, if we try and put this code in the console, it'll crash because it's saying %s is your first one. It'll look for a string as your first variable. If that's not a string, it'll tweak out. But if you wanted to do this, you could signify that, hey, don't worry, my string is on index 2. And then you'd have to specify your O's, say, I don't think you have to, but I'll do anyways, is on index 1. So now Java will be like, oh yeah, this is 1, this is 2. Don't worry, I understand what you're saying. And it'll be able to relay this and then relay this. And we can test that in the console. So going back to our Salio's example. Let's name O's and we'll define it up here. And sorry, string name equals Sally. Double O's equals 42, 38. I know it might even just add in the extra stuff. And then add in that, say, 0.2 this time. Oh, sorry, I need to make this an F2 because doubles, integers don't have precision. Excuse me. So let's do the example. You'll see if you run this, it works normally. Excuse me. Yep. But if you were to swap this around and then try and run it, you'll see that, hey, this errors. Illegal format exception, %f is not equal to a string. So it's going to kind of crash out at that. Now I think you might be wondering why %s actually worked here. And it's probably due to the idea that you can pretty much turn anything into a string. You know what I mean? Like, that is a string. So I think that's what Java does internally, but you can't take a string and make it into a double. That's impossible. Unless you're using, we'll work with later. If I made this. Okay, no, let's even try that. Anyways. So you'll see this will error out. So what we actually have to do is specify our position. So we'll say, hey, my string is position 2 and my name is position 1. Oh, sorry, this should be in here. Everything is inside this percent sign. So all your flags, everything is contained in this area. So now when I run this, you'll get the right output. And can I actually ignore this? I think I can. Because we only have two variables, but if I said and is %d years old, then I added 12, I think we're going to start seeing an issue. D is not Java lang, yeah. So now Python is kind of confused, sorry, Java's confused on what we're focusing on now. It doesn't understand what D is supposed to refer to. It doesn't understand what this is supposed to refer to either. So if we made this, if I signified that I want this to be 1, why is this still being a bit weird? I think I need to signify this is the third one. Yeah, there we go. So you just have to specify it all, and then you'll get this. So yeah, that's how you run this. And I think maybe the reason you don't have to specify, I don't understand why I have to specify the float, but I don't think that matters for UILCS because on the state test when I saw this, they write this all out. They write this, and then they write this, and then they write this. Maybe my only guess is I'm going to assume that Java is now looking at this as like a string or something, not really as a print. Because it's saying it found 3 arguments, but only thought 2 would exist. So let's specify this as 3 here. Oh, because, boom, 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 watch this. This won't error because it's %f, and so if we made this %c or something, and then I made this into a character. Huh, I wonder why then. I'll probably research that and just put that in the end of the video, but it's kind of getting late right now. But all I need to know for this positional argument is position that's index based, starting at 1, then your $, like that, and it will correspond to that symbol. Let's go back to our original example. And yeah, so you'll see that now it understands perfectly what I'm saying versus without these positional arguments, it gets confused. We're gonna error out. Okay, and that is your print statements in Java. Even though there are still some loose questions at the very end, I've covered everything you definitely need to know for the exam, for the written test.